In this video we're going to look at two problems using geometric series. The first problem says, find to the nearest integer the sum of the first 11 terms of a geometric series with a first term 5 and a second term 6. So let's start off writing out the key information that we know. We have our first term, which is our a value, which is 5. We can also write down the common ratio, which we can use because we have the first term and the second term. So we can use second term divided by first term, which gets us 6/5. Now, in this problem, we want to find the sum of the first 11 terms, so we also know that our n is equal to 11. Once we have those, we just need to use the summation formula. So our sum of the first 11 terms is equal to our a value, which is 5, times 1 minus rr, which is 6/5 to the power of 11, all over 1 minus 6/5. Now we can simplify this a little bit. 1 minus 6/5 is minus 1/5. 5 divided by minus 1/5 becomes minus 25 times 1 minus 6/5 to the 11. So at this stage I'd go to the calculator and you end up with 160.7520927. You then look what the question asks for and it says give it to the nearest integer. So we can round this then to the nearest integer, which is 161. And I just put that in brackets. So nearest integer. So that's quite a nice problem. And then we move on to the second problem then, which says the fifth term of a geometric series is 16 and the third term is 4. Given that r is positive, find the sum of the first 10 terms. So this is going to require a little bit more work, but let's set up what information we've got. So we're given the fifth term is 16. So we can say that u5, which is equal to, now we don't know the a or r, but we can write this as a times r to the power of n minus 1, which is 4, is equal to 16 using the nth term formula. Similarly for the third term then, u3, which is equal to a r to the n minus 1, so 3 minus 1, which is 2, is equal to 4. And if we divide these two terms, so if we go and say, well, u5 divided by u3, we get ar to the 4 divided by ar squared, which when we simplify that gets us r squared is equal to 16/4, or in other words, 4. So from this, we can say that r squared is equal to 4, just off the definitions of the third and fifth terms. Further into the sentence then, we're told that r is positive. So as r is positive, it's greater than 0. This implies if r squared is equal to 4, r must be equal to plus 2, or 2. Now, we want to find the sum of the first 10 terms. So we know our n is 10, we've got our r value, but we still need to get a value for a yet, what the first term of the sequence is. To do this, we just need to use our formulas. Now, because we know r squared is equal to 4, we can substitute it in, say, into the third term. So using u3, and say that we've got a times our r squared, which is equal to 4, is equal to 4. So if 4a is equal to 4, a must be equal to 1. So it's quite nice for this sequence. So we have our a value, we have our r is equal to 2, and for this problem we have n is equal to 10. It's at this stage we just need to use the summation formula. So we can say that the sum of the first 10 terms is equal to a, which is 1, times 1 minus rr, which is 2, to the power of n, which is 10, all over 1 minus rr, which is 2, 1 minus 2 is minus 1. 1 divided by minus 1 is still minus 1, which actually means that we can just rewrite this as 2 to the power of 10 minus 1. Now, 2 to the power of 10 is 1024, take away 1, and we are left with 1023. Obviously, your calculator will help you with that, but if you are good with numbers to do with computers, you might recognise 2 to the power of 10 as well. But that's our final answer for this problem, and that's how we solve these two problems on geometric series.